Taylor and Kate, what we did was, we've been looking at 6.3. It's using proportions instead of a mean. So we changed your population parameter. Instead of doing a sample mean to estimate for a proportion mean, we're doing a sample proportion to estimate for a population proportion. This little thing here is called p-hat. And p-hat, a proportion is a part over whole. This is how we find your p-hat. So sometimes they give us our p-hat, and therefore we can find our q-hat by 1 minus p-hat. Now in this example, they had you use this chart. So they said people over 65, so what is your p-hat? Therefore, according to your chart. You guys did this yesterday before we left. So what's your p-hat? 0.25. So therefore, what is your q-hat? 0.75. P-hat and q-hat are just denoted for your sample. It's a proportion out of the 498 U.S. adults. It came off their graph. Out of 498 surveyed, X amount said that they thought teenage drivers were more dangerous. X amount said they thought people over 65 were more dangerous. So they made a proportion themselves, and they gave us the p-hat. Sometimes we make the proportion. And I'll show you in a minute, if you're going to use your calculator, you have to make the x out of it, back out of this. So we said, okay, same setup. Instead of x bar plus or minus e, it's p-hat plus or minus e. Now your p-hat is the point estimate that we use for your population proportion, just like we used your sample mean to estimate your population mean. So your margin of error is the wiggle room off of that. Excuse me. So we have a separate formula for this, but notice that this also uses the z-score again. So we do p-hat, q-hat over n. And now I'm going to give you the formulas so you don't really have to worry about it. Now they want you to construct a 99% confidence interval. And from the example 3, we found that for a 99% confidence interval, the ZC is 2.575. And how did we do this? We put this in inverse norm. 1 minus 0.99 divided by 2. And we found the ZC associated with that score. Okay? So we come back over here. 0.575. Here's your 0.25 times your 0.75. And they told us they surveyed 498 people. So again, your margin of error is going to be small because it's a proportion. So your margin of error comes out to be 0.05. So all we have to do is say 0.25 plus or minus 0.05. So from 0.20 to 0.30. What does this mean to me? It looks a little better if you go like this. It means that I estimate the percentage of all U.S. people that think, all U.S. adults that think people that drive, people that are over 65 are our most dangerous drivers. I could be 99% confident that the proportion of all, the whole population will fall between 20 and 30%. In other words, 20 to 30% of the whole population in the United States think that the most dangerous drivers are people that drive over 65 years old. Does it make sense? We're still making an inference about your population based on your sample. But now instead of a sample mean, we have a sample proportion. Our parameter has changed a little bit. We're still using your z-score. We're still setting it up the same way. Good? Good. Okay, now the last part is finding your sample size. Remember we did this with the z-score, but we did not do it with the t-score. So with the z-score, we found your sample size. And we're going to do the same thing for proportions. Only it has its own formula because it comes off of this. So if you squared both sides, or first divide this by ZC. Let's divide this by ZC first. And then you squared both sides. You get this. Oops, sorry. And then all they did was they flipped this over. They flipped this over, or cross multiply it if you want it first. And then I would just say flip it over, it'd be easiest. And solve for n. It's the same formula solved for n. I'll give you this format. Now, there's only one problem. Sometimes you don't have a preliminary estimate. Like for the polling is a great example. You don't know who's going to vote for Rubio, the lesser, or Cruz, because they've never run for president before, or any of the other ones except maybe Hillary. But you don't know what their P's and their Q's are going to be. So if you don't have a proportion that was already established, we're going to use 0.5, 0.5. This is 50%, 50%. So we'll assume that half the people in the country will vote for Hillary, half the people in the country will not vote for Hillary. So that's how they establish this, if there's nothing to go by. Obviously, though, if you know previous information, you're going to be a little bit more tighter in your sample. So your sample size should go down a little bit. This will give you like a maximum sample size that you should use, in case you don't know any preliminaries. And a lot of times you don't know any preliminaries. So let's take an example here. You are running a political campaign. This is perfect. And you wish to estimate within 95% confidence the proportion of registered voters who will vote for your candidate. Your candidate has never run before. Now, your estimate must be accurate within 3% of the population. So when they say Hillary's ahead by 34% plus or minus 3, that's her wiggle room, that's her margin of error. You need to find, this is what it's asking, the minimum sample size needed. So when it's asking me to find the minimum sample size, I gotta have an n equals. That's what I think first. First of all, if no preliminary estimate is available, then p hat is 0.5 and q hat is 0.5. And then we'll do this again when p hat is 0.31. So sometimes they have something available, sometimes they don't have something available. All right, so let's take a look at this. So we're going to use your formula. This part looks a little familiar, this part. Doesn't this look familiar times the standard deviation things we had out here? Not the standard deviation, the sample things we had out before. Actually, we had your standard deviation in here. Sorry, my allergies are kicking since we went outside. So, this is n. So, plug these, all you're doing is plugging these in. My ZC, what is the ZC associated with the 95%? How do I find that out? You could look at your chart, or it's going to be hard to look at your chart. You're going to do 1 minus 0.95 divided by 2 in your inverse norm. Remember, this is a ZC. Inverse norm deals with ZC. Because it's saying this, 95% falls in the middle. You have 5% to share. What's half of 5%? 2.5. So if you look this number up for 0.025, just make sure I get the positive. So what do I get? 1.96. Good. What's my margin of error? 3%. But notice I'm dealing with decimals. So how do I write 3%? 0.03. Good. And I'm going to take this and I'm going to square this. Now, you can put this entire thing in your calculator. just like you read it. Just make sure you don't square the 0.5 times 0.5. And same rules hold as with the other one. You always round up. Because can you survey a partial person? No. If you round down, then you haven't hit this number yet. You need to round up. Yes.
Why is the P.5?
Because at first they said, say you have no preliminary estimate. Say you've never done this before. I don't know like who's going to vote for my candidate. So I'm just going to say 50% of people will, 50% won't. Then we're going to do it again.
What would you take for like when you make your inference of the population?
Well, this is just finding your sample size. This only happens with your sample size. This doesn't happen with your regular Z-score thing. We'll give you the page. We'll tell you what percentage you have to use.
It says like within the 3% of the true population.
Right, because remember whenever we found the sample size, we had to know your margin of error.
But that's not for the...
But then
that
this...
wouldn't be the error for the sample. It would be the error for the actual population.
Well, it will be your error so that you can make that interval. Like, you want to say, I want to be within 3% of the numbers. So when I actually do this, whatever my interval is, it's my plus or minus 3%. How many people will I need to get within that interval?
That's for the sample.
This is to find the sample size. Now, say I did this before, and I know 31% of the people voted for my candidate. So now, instead of using the 0.5, I can absolutely use their p-hat and q-hat. Watch what happens to your n. This is going to stay the same. I still want 95%. I want a 1.96. I still have my margin of error, which is, what is my margin of error? 0.03.
Yeah.
Make sure you turn that to a decimal. Otherwise, you're going to divide by a big number, and then you're going to get like nobody in your sample. Square the sky. So now you should find a little smaller. Always round up. And if you know your preliminary, you should have a better feel for it. So you'll be better to get in that ballpark. So therefore, you should need a little less people in your sample. A little tighter controls. But Julia, don't confuse this p-hat of 0.5 with when we do a regular example for confidence intervals. We'll never not be told the p-hat to find a confidence interval. This is just to find your sample size. So here's my new candidate. I'm in charge of this new candidate. Michael's running for President of the United States. I'm in charge of his campaign. I need to know, within a certain margin of error, how many people I think will vote for him. What proportion of the whole United States people will vote for him? So I have to sample people, don't I? I have to know how many should I sample. That's my first concern. I have to make it as random as possible. I'm going to follow all my rules of random sampling. But I have to know how many people should I put in my sample. So first time through, I don't know what my P's and Q's are. I'm going to use this. So I'm going to say, I want to be 95% confident. This is typically how they look at it. I want to be within 3%. If you notice, most votings are within 3% or 5%. Usually a 3%. So I'm going to sample 1,068 people. Now, when I do this again, I already know what percentage of those people actually did, in that sample, did vote for Michael. He ran already. I know who in the United States voted for Michael. So 4 years later, he goes to run again. I know how popular he was. He had a 31% proportion of everybody in the United States. So now I can use 31%, 69%, and come within that sample. And I want to do this again. So sometimes you have a preliminary, sometimes you don't. And that only happens with your sample size. But this is key. These are the words you want to look for. Find the minimum sample size. Okay? Alright, so you guys are going to try this next one. You are going to try it yourself 4. And look what it's asking you to do. Do it 2 times. This is when you don't know. This is when your preliminaries are here. Standard. And then this one, you found one preliminary study for 31%. They use 31% again. Yes, they did.
Must be accurate within 2% halfway.
So it must be accurate within 2%? What does that mean? There's your margin of error. So how do I write this? 0.02. Remember, you're setting up a proportion. We don't really... Alright, so now we've got 2 situations. One where they weren't sure about any background information, so we're going to make it 50-50. 50%, 50%. One where, oh yeah, they did a previous survey before, and they found 31% of those U.S. adults to have had an HIV test. So our Q in this case again is 1 minus this. And we're going to see what happens. When you have preliminary information, your sample size should be smaller. This should give you the largest one. So your sample size again, find the minimum, this is what you're looking for, the minimum sample size. This automatically tells me I want the N equal formula. So N equals my P hat, my Q hat, my ZC, and you can put that in like you read it. Just make sure you don't put these in the parentheses. So just plug it in. This is a 90% confidence interval. So what's my ZC associated with 90%? 1.64, 1.645? What's my margin of error? 0.02. I need to be within 2%. So N, again, I always have to round up. No matter what the rounding looks like, I have to round up. I have to survey 692 people in this survey so that it's valid, so that I get a good sampling. Then, say I did this the following year, so now I know from my group last year what their P's and their Q's were. So now I'm going to use those instead. This is the only thing that changes right here. This is going to stay the same. And now you're going to get a little bit smaller. Again, round up. So it's a little bit more exact if you already know some information about it, which would make sense, right? Because you can pretty much use that information in the next part of it. You guys have any questions? All right. I'm going to give you a little assignment from the book. And let's have you do page 325 to 328, 1, 4, 6, 11, 14, 17, 20, 21, 22. Oops. Didn't quite make the top of that. There's no calculator step for your N again. There's no calculator step for the N. For the intervals, you can always use the 1 proportion Z interval step. I'm fine with that. Let's see.